Hi, my name is Fabrice TROLLET and I am the MaTeLo Product Manager at All4Tech. Welcome to this MaTeLo tutorial session 1. You are going to learn how to design your first MaTeLo model with simple data and generate your first test suites. Create a new project clicking on New MaTeLo Project. And this project will be named Cruise Control. Open this new project and open the first chain with a double click on root chain. Let's create the first state of the system. This state is when the vehicle is started. Call your state with a past participle, so here vehicle started. Create the first transition, which is necessary, which means that you are going to start the engine to reach the vehicle started status. Then, add a manual stimulation, used for manual testing. We will do it only for this transition. So write that you want to turn the key and start the engine, and a verification which is the expected result. Then, add the first numerical stimulation. So, create this numerical input and call it speed. Define its equivalence classes, its minimum speed to 0 and 150 for its maximum speed. Define the singular value with a speed of 0 and two equivalence classes from 0 to 50 and from 50 to the maximum. Now define the default distribution of speed and set it to rectangular distribution. Link this stimulation on the transition and choose 0 for its equivalence class as the engine is ready but not started yet. Then, create an output which will be used to check the speed of the vehicle. So, create this numerical output and link it, this time in the Verification tab. Indicate on the upper boundary that it is equal to the speed that you previously defined, so external input, and we don't use the lower boundary in this project. So define directly your expected values and not some various ones into boundaries. Then create the next state, which is under the pivot value of 50 km/h. Call it less than 50 km/h. And add a transition which allows to drive from 0 km/h to less than 50. So you want to accelerate to reach a speed which is under 50 km/h. Indicate the transition name, which is also the step name. Then link the numerical input speed and choose the equivalence class from 0 to 50 and set the two others to false. Proceed the same for the output. Indicate the expected result, defining that you want the speed to be equal to the one you just defined. Then create a state higher than 50 km/h, which allows to go from a speed below 50 km/h to higher than 50 km. Create this transition and name it Accelerate more than 50 km/h. And on this transition, link the speed stimulation and set its equivalence class to 50 to 150, so the others are set to false. Same process for the verification. You expect that the speed you just defined in the stimulation is the same in verification. Define now the way back, so how to go from the state in which the vehicle drives higher than 50 km/h to the state it is less than 50 km/h. So you have to brake, decelerate until you reach a speed which is less than 50 km/h. Set the equivalence class to true, the one which is between 0 not included and 50 km/h. For the verification, set external input and make sure the speed is the same as the one you just defined. Then you can exit the model. The vehicle shall stop first. It is the opposite of the project beginning, so vehicle stopped. To reach this state, the speed has to completely decrease until you stop. Define to stop the vehicle linking also the stimulation. So the input is linked in the stimulation tab. The equivalence class set to 0, and again, don't forget to set the verification at the same value that you just recorded. You are going to use these values later in this project. Then close the model with the same behavior that's at the beginning. As you started the engine, here you are going to stop it. It is also possible to change the speed when you drive at less than 50 km/h with a transition looping on the state, allowing to regularly change the speed within the defined equivalence class, with a rectangular distribution between 0 to 50 km/h. You can also check that pressing the cruise control switch, so enable cruise control. If you press this button and you are driving below 50 km/h, so we should remain in the state less than 50 km/h. Nothing happens, and you are going to come back to this state. Then untick the test step, so you don't have some empty test steps, as each transition can lead to a test step. Except when you untick this cell, and in this case it doesn't appear in the generated test case. Save the project and go to Generation View to see what you can generate from your model. Choose the minimum arc coverage algorithm, which offers to fully cover the model with the minimum amount of test cases. Open the test suite in HTML, clicking on the tab at the bottom left corner. You can now see the project and its generation in arc coverage, with the stimulation speeds, expected speeds, and their values, which are randomly chosen within the defined equivalence classes, and the expected result in blue on the right. If you have any question, feel free to ask them directly in the video comments. To be notified of our future MaTeLo videos, please like this video and subscribe to MaTeLo channel. And don't hesitate to connect and follow me on LinkedIn.